Hello everyone. Now let us continue with the design series. Today we will be looking at the chain of responsibility design pattern. So what is this chain of responsibility? It says that you can pass a request to a chain of handlers, and along that chain of handlers, along this chain of handlers, you can say like every handler can either process the request or it can pass it on to the next handler. It will be having either of the two responsibilities. So by doing this, we are actually decoupling the sender from the receiver. So that like even if we want to add a new handler later on, we just have to create a new class and we have to implement the base handler and we can pass a new request to the chain. So every time we pass a new request, it will be going on with the complete chain until unless it uh, reaches to the handler which can actually process it. So let us see how we can implement it. So what I'll do is I'll just create a new file, say chain responsibility.cpp hash include iostream using namespace std. So first of all, I'll be creating an abstract class so that the base class can actually handle some of the responsibilities. So we'll just go through it. So I'll create a class support handler. Inside the support handler, we can create a constructor support handler. It will be taking uh, okay. It will not take any handler as of now. What we'll be doing is we'll just set the handler as null. What I mean is that every support handler will be consisting of a support handler pointer. Let us name it properly, next handler. So it is the next, you can assume it like a linked list. So it will be holding the pointer to the next one, right? So now in the next handler, I can just set null PTR as of now. Then we have a set next handler method, which will be taking a support handler pointer next, and we'll just set the next handler to next. Right. Now, what we'll be doing is we'll create a handle request method, which is void handle request. Inside the handle request, you will be getting a message and let us say a level type, which will actually identify which handler has to process the request. So the message, I would say, like we can take const string ampersand, let us say issue. There is some issue and there is one level. Along this level, you have to perform some tasks. Now, as I said, that we have a series of handlers. So I would like to make it virtual because I want to achieve like polymorphism so that every time uh, the base class object is called, at that time handle request of the base class should be called. So I'll just make it virtual. Inside this, I'll have if next handler. You can make it pure virtual as well. It is completely on the like requirement. Why I'm not making it pure virtual is because we have certain common functionalities which will be there. So I can keep it in the base class. That's why I'm not making it pure virtual. So let us say if my next handler is not null, then in that case, my next handler's handle request will be called. and I'll just pass the issue and the level. In case if it is null, then I'll just see out, let us say, a log which is no handler available, right? So with this, the base class is completed. We can also add a destructor here, virtual support handler, right? This the base class is completed. Now we have to create levels of this. So what I'll be doing is, let us create a class called basic, let us say basic support, which will implement publicly the support handler. Now inside the support handler, I have to override the method which is handle request. So I'll say void handle request, again the same argument, string issue and one int level, let us say. Now I'll have a check if my level matches the basic uh, support. It means if the level is 1, we are assuming that level 1 is for the basic support. So if it is level 1, then we'll be handling it. So I'll just see out a log that level 1 support resolved, let us say. And we can also print the issue. Let us give a space over here. Else, what I'll be doing is, I'll just call the parent class support handle request, and I'll pass the issue and I'll pass the level, right? This we can do. In case if you're making it pure virtual, what you can do is you can keep this next handler inside protected visibility, and you can directly call the next handlers. In that case, you have to check whether it is null or not. Every time you have to check in all the base classes. So to avoid that, I have already written the next handler's code inside the base class, so that every time here we do not have to check whether the next handler is null or not. So this is my base support handler. So let us go for the intermediate support. Again, it will be publicly implementing the support handler, void handle request const string ampersand issue int level. If my level is now 2, then in that case I'll be handling this issue. So I'll just log out level 2 support resolved, and then right, else we have to do something, which is again calling the parent class to handle the request issue comma level. As the last class, we'll make it as a manager. Let us say class manager, again publicly implementing the support handler. Inside this, void handle request const string ampersand issue int level, again checking if the level is equals to 3. In that case, I'll be handling it. So cout level 3 support resolved issue handle, right? Else, I'll again call the support handle my parents class handle request with issue and the level, the same arguments. Now, how we can make use of it? Let us make int main. The client will be using it. So we have the basic support first. Let us name it level 1. Now we have the intermediate support with level 2. And next we'll create a manager. Let us name it manager itself. Once this is done, you have to set the support handlers. So let us say level 1 dot set next handler to level 2, and level 2 set next handler to manager, right? Now with this, you can call the handle request by passing any level of request. Let us say level 1 dot handle request, and I'll pass say we have a password reset, and we assume it's a level 1, let us say. And we'll also make another example. Let us say level 1 dot handle request, and we are having system crash, and it's a level 2, let us say. Also, let us make it level 1 dot handle request. Let us say rename it what device not working, and let us keep it level 4, which is out of the scope of all the handlers. Let us see what it does, and will return 0. Let us save it and give a compile to see if there are any errors. So G++, we have chain responsibility. Let us name it chain. Okay, we have one error, which is IOStream. We spelled it wrong. Now it is correct. Again, let us give a compile. Okay, we are passing the object straight away. So we are taking it as a pointer. So we have to pass the address of these objects. So I'll just pass the address of this. Now let us give a compile again. So in the interview, if you face such errors, you should be able to identify the errors very easily, so that you can show the interviewer that you have complete knowledge and you know what you are doing, and you can correct the errors very easily. Since you are able to identify, you can like show the interviewer your knowledge. Once this is done, let us execute this. So you can see level 1 support was there. Level 2 support is also got printed. When we pass a level which is out of the scope, it says no handler available. So this is the way how we implement the chain of handler support. Let us say, so these all the manager class and the intermediate support and these classes will be there in separate files, let us say. And in future, if you want to uh, add another support, then in that case, you just have to create a new class. Sorry, you just have to create a new class, and you can like override the handle request method. And inside that, you can check your level. Say if you want to add a new level for 4. As of now, we are not having one. So if we, in the future, if we try to add it, we just have to have a level check of 4, and we can just add it straight away. And here we will be adding it into the next handler. So it will work without modifying the rest of the classes. So that is the advantage of using the chain of responsibility. So with this, we are done with the chain of responsibility design pattern. We'll be coming up with many more design patterns, and then we'll be looking forward for the design questions in depth, and we'll be looking at how we can make use of these system designs in design patterns into the system design questions.